Hello everyone, welcome back to my channel InfoSec Lab, and today is gonna be another video of try hack means attacking and defending AWS services. Now, as we may have learned that we have gone over some introductions about AWS and AWS IAM, and then we have gone over some IAM principles in AWS. Today's room we are going to over some IAM permissions. An IAM principal can have multiple policies attached to it. These policies determine what the principal is authorized to do in your account. Each policy consists of one or more statements consist of an optional statement identifier known as SID, action, a list of things the policy allows or denies, resources, the ARNs of resources of the statement applies to, effect, either allow or deny, condition, optional conditions that must be satisfied for the policy to grant permission. AWS provides many AWS managed policies that contains a list of actions that usually map to a specific job function. However, AWS customers can also create custom policies that are more fine-grained. For example, you can craft an IAM policy that only allows someone to read from one specific S3 buckets, or to start or stop up but not terminate a specific EC2. Customer policies can either customer managed policies or inline policies directly attached to a specific principal cannot be shared. Inline policies are best to ensure a direct relationship between a principal and the policies granted. In contrast, managed policies can reuse the policies across multiple principals. The most powerful AWS managed policy is the administrator access policy shown as below. So the command line to use it, again, before using any commands in this room, we have to configure the AWS account that is provided to you. And because the credentials, the access key and the secret keys are sensitive, I have already configured my AWS account. If you want to know how to do it, then go to task number 2 right here. There's instructions from TryHackMe how to configure your AWS account. Okay, so let's try this AWS command, AWS IAM, get policy, and then policy ARN. This specifies the name of the resource of the policies. Okay, there has been a typo. Let's try one time. AWS IAM get policy ARN, and okay, so this is what it looks like. Looking at the policy statement, we can see it allows all actions on all resources. Statement, effect, allow, and then action, everything. The asterisk mean that everything. Resources, everything. Wait, where is it? Oh no, this is only get the policy right here, and then we can try this command right here. AWS IAM get policy version, policy ARN, and we paste the ARN version ID v1. Okay, looking at this policy statement, this is the statement that we were looking for. The statement here, the effect is allow or deny. In this case, it allows because it's the administrator access, so it allows. Action, all the actions are allowed, and then all the resources are allowed for the action to be to be acted upon. So in the remaining tasks of this room, we will go through all the different elements of an IAM statement in more depth. There is another managed policy called read-only access. Using the commands above, go look at the permissions granted granted to the read-only access user. At the time of this writing, the version was version 83. Use the AWS command CLI to answer the follow question. Okay, so AWS IAM get policy version policy ARN copy paste. Now we have to modify the name of the policy, which is read only access, and the version ID is going to be v83. Yes. Oh, okay. What is the policy ID of the read-only access managed policy? Policy ID right here. Okay, it's got a bunch of actions. Okay, that's a long one. Let's try the grep command. Policy ID. Okay, let's get some help. How can I look for policy ID from the... Again, I'm using ChatGPT to help me with this command. Okay. Okay, how about we try this command to see? Oh yeah, we try this one. So I was using the wrong one. Get policy and then policy ARN. Sorry guys, I was using the wrong AWS command. It should be the correct one. Paste. And this is the policy ID. Copy and paste it here. Alright, here task number 2 is just instructions how to configure your AWS account. So complete it. Action. Actions consist of a service and an API call. Some examples are EC2 stop instance. So this is the service, and then this is the API call. S3 get option, SCS assume role, IAM list users. In the above examples, EC2, S3, STS, and IAM are the services, while stop instance, get object, assume role, etc. are the API calls. Actions are case insensitive. However, service names are almost always written in the lowercase, and API calls match the cable case in AWS documentation. Actions support wildcards. So to permit all the actions for the S3 service, you can use an action of S3 columns and an asterisk. Or to scope To read only actions, you can use S3 get and then the asterisk. What is going on? AWS does not enforce consistency across service for API calls. Some services use describe asterisk, while others use get asterisk or list asterisk. So basically, depending on the services that you were referring to, the name of the action can be different, even though they all do the same thing, allows you to have some read access to the service. But in S3, they may use the get, but some other services they use describe or list. The complete list of IAM actions can be found here in this document. If you write IAM policies on a regular basis, you will probably want to bookmark this link. Okay, so this is going to be the link that we need to reference. What action grants permission to create access key and secret key for the specified IAM user? You can find a hint in the service authorizations docs for IAM. Okay, I don't know why it's keep disconnecting. What action grants permissions to create access key and secret key? Actions and conditions keys for, okay. IAM. Let's see. What action grants permission to create access key and secret key for a specified IAM user? Use the hint in the service authorization. Okay. Okay, AWS key space management. Can we try this one? Key management. Oh no. Okay. So we have control permission to cancel a schedule deletion. Control permission connect or reconnect a custom key. No. Control permissions to create an alias for AWS KMS. No. Control permission to create custom key store. Nope. Okay, control permissions to create an AWS KMS key that can be used to protect. Okay. Create. Nope, it doesn't seem to be the case. Let's try this one. Action defined by. This is the same thing. Let me see. Let's, if it's for IAM, I assume let's look at the IAM. IAM, where is it? Okay, we have several options right here. Oh, right here. There we go. Create access key. Grant permission to create access key and secret access key right here. So basically we go from this URL right here, click on that one and just look for IAM, not this page, click for IAM and then you select this option, AWS Identity and Access Management. Click on this one and you're gonna see the actions right here. Grants permission to create access key and secret keys for a specified user. Nope, IAM. Okay, moving on. Resource. Try reconnecting. I don't know why. What happened? A resource is always in an ARN format or a wildcard to represent any resource. Resources in IAM policies are essential to achieving the principle of least privilege. Suppose there are multiple applications or teams in a single account. In that case, least privilege will dictate what application A cannot access the data belonging to application B unless there is a business need. By crafting a policy that only permits application A to access S3 buckets belonging to application A, least privilege is possible. Recall that ARNs include the AWS region, account ID, and resource name as part of the ARN. ARNs are global like IAM, have an empty value on the region. Because AWS cannot identify what resources a customer may have, all AWS manage policy with the wildcard asterisk as the resource value. In the case of ARNs for AWS managed policy, since these are managed by AWS and not owned by anyone's AWS account, the account ID field is an empty value. In your account, there is a bucket that begins with try-me bucket dash and ends with your unique account ID. What is the ARN of that bucket, excluding the last 12 digits? Cool. Key S3 bucket, try-me bucket. And what is the ARN? We go to properties. This is going to be the ARN, try-me bucket, and then excluding this one. Excluding the last. Brr. Did it freeze? Okay. Effect can be either allow or deny. With AWS IAM, there is a default implicit deny. All policy statements that match the request action, resource, and conditions are evaluated. If there is any explicit deny, then the action is denied. Otherwise, if there is an explicit allow, the action is allowed. Otherwise, the final decision is to deny the request. So here's a chart of the policy enforcement. First, it starts as deny, and then it will be evaluating all the applicable policies. Is there an explicit deny? If yes, then the final decision is deny. If there's no explicit deny, we continue. Is there any allow? We continue with the policy to see if there's any allow. If yes, then decision is allowed. Otherwise, final decision is denied. Okay. For the following question, look at the policy. Okay, action easy to describe. Okay, this is to get the information of the EC2. All the resources. Effect. Okay. Secret manager, list secrets. Secret manager, get secret value. Okay. Given the policy above, can the user get the HR password? So remember, the actions are, so because we are interested in the HR password, we're not going to pay any attention to this, because these are only the permissions for EC2 and the circuit managers. So just ignore this one. We're going to take a look at this policy right here. These are two separate policies. Okay, so actions is everything, resource is AWS Circuit Manager US. Okay, secret HR password. All the actions on this resource are denied. So given the above, can user get the HR password? Nope, no. Principle. Only required for resource policy, not identity-based policies. The principal element specifies the principle that is allowed or denied access to a resource. If the principle is asterisk, the policy applies to anyone or all AWS customers, depending on the service. We'll cover the resource policies in the next group. The following resource policy grants public access to a read bucket, and only allows user to snap the ability to write the bucket. So here's a statement, SID. Sometimes it's there, sometimes not, because it's optional. And allow principle is all the services in AWS, and then action is get object, and the bucket is dark arts class nodes and anything inside that bucket. So basically, this policy, what it means is it allows all AWS services to read the content of this specific bucket. Here we go, get bucket, meaning that you have the read access. Okay, allow public read. Okay, so we have another policy that allow public read, and then in this case, only the user whose name is snap is allowed to put object or put object ACL. Put objects mean that you can actually modify the content of the buckets, meaning that you can add a file or removing a file or do anything, change the content of the bucket, and then put object ACL, meaning that this user also have the permission to actually set policy for the bucket. You can specify any of the following principle in a policy. AWS account and root user, IAM roles, role sections, IAM user federated user sections, AWS services, all principles. Okay, let's try that. Look in your account. What is the principle that is allowed to assume the organizational account access role? Oh, let's try this one first. AWS account and the root user. Okay, this is the AWS account. The root user, I don't think we can identify the root user. Is it? No, this is not. This is IAM user, not the root user. So this is the AWS account. Okay. Do we have any IAM role here? No, we don't have any IAM role. We have IAM user right here. IAM user. The name is snap. We don't have any federated user sections. We have all AWS services right here. All principals. Yep. Okay. Looking at your account, what is the principal that is allowed to assume? So in order to figure that, we can try IAM role. We look for this specific IAM role, organization account access role, right here. Take a look at the trust relationship. And we see that only the root user has the permission to so root is going to be as is everything. No. Look in your account. What is the principal that is allowed to assume the organization access role? That's root. ARN. Wait a minute. Wait, is it? Yes. So we have to include the AWS right here. I'm not sure what's going on with the VM today. It's kind of... Okay, it's correct. The answer is correct. Alright, moving on. Conditions. Conditions are optional elements that users can add to a policy. They evaluate against specific keys and values in the context of the request. The context of the request is specific to action and resource type. For example, the condition keys available for S3 can be found in the S3 actions table right here. This is another AWS documentations. Okay. All conditions must be met for the condition block to evaluate true. However, if multiple values for condition key are provided, the presence of any of those values allows the condition to return true. Okay, let me read again. All conditions must be met for the condition block to evaluate true. However, if multiple values for a condition key are provided, the presence of any of those values allows the condition return true. Okay, let's see. Condition 1, key 1, value 1a or 1b. So either one, and let's move on to see if anything make more sense. Condition statements have special operators that are used to evaluate the condition. Examples are string equals, string not equals, string not like, string like exists, string like if exists, etc. There are a number of global condition context keys that you can add to your statements based on the attributes of the API call. One of the most common one is AWS source IP, allowing or denying an action based on the IP address it's coming from. Another popular context key is AWS resource tag or tag key. This condition key can be used to grant or deny access based on the specific tags of the resource. If the statement were allow actions is allowed to terminate an EC2 instance, any EC2 instance, and then with the condition that the resource tag is Hufflepuff. Okay, here's the explanation. The principle with this rule would only be granted access to Hufflepuff EC2 machines. If the machine were tag house Greenhoff, the allow effect would not apply. Okay, so it only applies to the EC2 instance with a tag Hufflepuff. This use of AWS resource tag is a fundamental building block of attribute-based access control, or short for ABAC. In the next room, we'll see a global context key, AWS Principal Original ID, used to ensure only members of the TriHackMe community are able to invoke a Lambda function. Given this statement, okay, we have deny. All the principals have that are denied to modify S3 buckets. And then my logs bucket, AWS logs account number, okay. Everything inside this account number, string not equal. Source VPC is VPC ABCDEF2, principal service name glue amazon.com. Okay. The glue service running VPC 12345 can write object to my log buckets or not, true or false. Okay, let's see. So we have everything here. Okay, let's step one step back. Over here, we have another popular context key, AWS resource tag. The condition key can be used to grant access or deny by on the specific tag. The principal with the rule would only be granted access. Okay, this is only allowed with the condition that the string is equal. If the string is equal, this one, okay. This is deny if the string is not equals VPC, if the source VPC is not VPC ABCDEF2. Okay, and the principal service name is glue amazon.com. The glue service running on VPC 12345 can write an object. Okay. To make it more easier to understand, I'll try my best to explain it. But basically, what this policy say is, if the source VPC is not VPC ABCDEF2, and the principal service name is not glue Amazon AWS.com, then it will be denied to modify the S3 buckets. So in this case, the service name is correct, the principal name is correct, which is glue.amazon.aws.com. That's true. However, VPC ABCDEF does not match the name of this VPC 12345. Therefore, we are not allowed to write an object to the mylogs bucket. So can write is false. I hope it makes sense to all of you. Okay. Continue. Not action, not resource, not principle. AWS IAM has a concept of not action, not resource, or not actionable, or not principle. This can be used in more complex cases, but be careful. Doing an allow on all principles except one would allow all AWS customers access the resource. You can use not action to grant broad access to an account while reserving sensitive actions for special administrators. This is one way to allow someone to administer an account but not modify the network. Not principal is useful for explicitly denying access to a resource except for a small number of users. For example, this policy will explicitly deny access to the Dynamo table Forbidden Forest to all users of account 12345679901 except Hagrid. This policy will explicitly deny, okay, so it will deny everyone. So to make it easier, usually without the not, this statement would mean that only Hagrid, only the user Hagrid is denied to have access to the Dynamo table. Now with the not, it's kind of reverse that, now only Hagrid has the access to that Dynamo table. I hope it makes sense to you guys. Alright, another way of protecting access to something would be via not resource. The same policy prevents mod user 012345679990 from accessing the Forbidden Forest table. Okay. Would be via not resources. Okay. We allow all users to access to modify the Dynamo DB. Okay, but not the resource, but not the table Forbidden Forest. So what it means, like in the Dynamo DB, there can be multiple tables, and basically all users have permissions to modify or to get access to all the tables within the Dynamo DB, except for this specific table Forbidden Forest. This is the only resource that all users don't have access to, or don't have the permission to modify. Alright, so basically that's what it is used for. Now all the students at Hogwarts have access to put any Dynamo DB table except for the Forbidden Forest table. Yep. Answer the following question. As Headmaster, Dumbledore's IAM policy is allow all actions on all resources. Would he have access to if the second policy were in this place? So if this one is placed after this policy, would he have access to the Forbidden Forest if the second policy were in place? So this one, allow everyone, okay, all actions on all resources. Yeah, I would say yes. Ooh. And then we're done with this room, the IAM permissions. So it might be a little bit confusing, but the more you get onto that, the more familiar you get with the IAM policy and statements. It may be confusing at first, but it is very beneficial for you to actually understand when you look at a policy or statement, you know what it is and what those key value pairs are, because in the future, when you work in AWS cloud, eventually you have to come across these kind of policies, and you need to know how to set permissions or how to restrict access to certain resources based on some access control implemented in your companies. All right, I hope this makes sense to you. If you have any questions, feel free to reach out to me, and I'll happy to help you. And thank you very much. I'll see you next time. Bye.